All right, so let us begin. Um, the objectives for today's class, we have 60 questions in which we want to attempt from the Chemistry 2015 past paper. There's something I need to find out from you first. Do you want to attempt the paper first, or do you want us to go through the paper together? All right, so I have one comment saying that we should attempt the paper and go through it. Okay, so what I'm going to do, I'm going to divide the paper into portions of 15. Right, so if you do 15, you do 15, then I correct 15. You do an next 15, then I correct it. You do an next 15, and then I correct it until we reach 60. All right, I would have emailed you the paper in your email. So along with the link to this Zoom meeting, you would have also gotten the paper. You can download the paper and you can start from questions 1 to 15. All right, when you finish and you reach question 15, you would send me a message in the chat and tell me that you're finished, and then I start going through the questions from 1 to 15 until we reach the 60. All right, so first thing I want you to do is go into your email, download the paper, and attempt the questions from 1 to 15 for me, and then we'll go through it together. Okay, so I'm going to start answering the questions from question 1, and you see how we do with them. All right, so question 1, which of the following processes provide evidence of the particulate nature of matter? Now, when we speak of the particulate nature of matter, we are simply saying that matter is made up of particles. And they're asking you which of the concepts or processes that they have there supports that notion. All right. So let's take into account each of the processes. Capillarity is the ability for particles to cling to each other. It could either be in the form of adhesion, where different particles are clinging together, or cohesion, where the same particles are clinging together. For example, let's say we have water. One water molecule will cling to another water molecule, right? And you can have the constant or continuous flow of water molecules from one location to another. But if we have the water inside of a glass container, the water particles can cling to the glass molecules and thereby giving us adhesion. So cohesion would be when the particles are the same. Adhesion would be when the particles are different. Now, just to recollect, this matter is anything that has mass and occupies space. And all materials inside of the universe are made up of matter. And there are millions of different known chemical substances that we have, and we could either classify them in terms of being solid, liquid, or gas, and they are made up of particles. The particulate nature of matter confirms that matter is made up of particles. Right? And of course, we have different properties that support each concept. So with that in mind, let's go back to the question. The question asks us which of the following processes provides evidence. Now, although capillarity involves adhesion and cohesion, it does not provide evidence that matter is made up of particles. Diffusion is the movement of particles from a region of high concentration of the particles to a region of lower concentration of those particles. So diffusion supports the particulate nature of matter, that matter is made up of particles. Filtration does not tell us that matter is made up of particles. right? Filtration is the process whereby we try to separate two substances where the particles are too large to pass through a filter paper, and we are able to separate one from the other. This does not tell us that matter is made up of particles. Osmosis is the movement of water molecules from a region of higher concentration to a region of lower concentration of the water molecules. So therefore, this involves particles and this involves water molecules. So these two processes, diffusion and osmosis, they provide evidence that matter is made up of particles. That's what they do. They provide evidence. So to question 1, the answer is D as in dog. 1 and 2 and 4, not 1, sorry. 2 and 4 is the answer, diffusion and osmosis. All right, D as in dog, that's our answer. All right, going on to question 2 now. Question 2 says that the mass number is the number of, and we have A, B, C, or D. All right, so at this point, you'd be like, what is that again? I'm trying to remember. So let me bring back some things to your remembrance. The thing to remember here is that the mass number of an atom tells you the number of protons and the number of neutrons inside of its nucleus, right? So mass number is equal to number of protons plus the number of neutrons, right? Now, number of protons is also equal to the number of electrons, right? Number of protons also equals the number of electrons. So number of protons plus neutrons is what we are looking for. Protons plus neutrons. That's what we are looking for. So let's go back to the question. Mass number is the number of protons plus neutrons. They have neutrons plus protons. So our answer here is A as in apple, neutrons plus protons. So it's not neutrons minus protons, it's not electrons plus neutrons, it's not electrons plus protons, right? The answer is neutrons plus protons because that is what the mass number is. So the answer to this question is A as in apple. All right, moving on to the next one. Question 3. Which of the following elements has 7 electrons in its outer shell? Which of the following elements have 7 electrons in its outer shell? First, to understand this question, we need to figure out how much electrons are in the outer shell of hydrogen, oxygen, nitrogen, and chlorine. Hydrogen has 1 electron. Oxygen has 6 electrons in its outermost shell. Oxygen is 2, 6. Nitrogen has 5 electrons in its outermost shell. And chlorine has 7 electrons because chlorine is 17. Nitrogen is 7, oxygen is 8, and hydrogen is 1. Right? So it looks like the answer is D as in dog. Right? But let's just take a look at the structures of these different elements. So nitrogen has 2 electrons in its first shell and 5 electrons in the outermost shell. Right? So 2 in the first and 5 in the second. Hydrogen just have 1 electron. Oxygen has 2 electrons in the first and 1, 2, 3, 4, 5, 6 electrons in the outermost shell. And chlorine has 2 in the first, 8 in the second, and 7 in the third outermost shell. All right, so with that in mind, let us go back to the question now. The question says, which of the following elements has 7 electrons in its outermost shell? And the answer to this question is now D as in dog, as we predicted. D as in dog, 2, 8, 7. Chlorine has 7 electrons in its outermost shell, making our answer D as in dog. Question 4. An atom that has 20 electrons when it ionizes has the same electronic configuration as, so we need to figure out what is the electronic configuration for these different elements and which of them has 20 electrons in it? Right? So argon, you have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Right? And then you have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, you have chlorine, potassium, you have argon. So argon is down somewhere 18, 19, going down on that side. So you have 2 elements in the first, 8 elements in the second, and 8 elements in the third as argon. All right, it has completely filled shells. So that's number 18. Calcium is element number 20. So this is 2 elements in the first, 8 in the second, 8 in the third, and 2 in the next one. So this is 20. Neon is 10. So that's supposed to have 2, 8. And sodium supposed to be 11, 2, 8, 1. Right? So the one that has 20 electrons when it ionizes should be calcium according to our predictions. All right, but the question would come to us, what is ionization? When we talk about ionizing, what are we referring to? When something undergoes ionization, it means to say that when energy is supplied in, an electron gets free, right? So its ability to give up an electron and become an ion, right, is what we refer to as ionization. So in that essence, when an atom is going from an atom to an ion, you have ionization taking place. Okay, fair enough. So let's go back to the question now. The question asks us, an atom that has 20 electrons when it ionizes. So some atom, when we ionize it, it has the same electronic configuration as the element that would have 20. And that would be our answer, B as in boy, because calcium has 20 electrons. Right? So that makes our answer B as in boy, because it has 20 electrons. Okay, so moving on, question 5. Sodium 2411 and sodium 2311 are isotopes because, so let's look at our options. They say because it conducts electricity. No, that's not a reason why something is an isotope. Because they react vigorously with water. No, that's not a reason why something is an isotope. Because they have the same relative atomic mass. This is a question mark. And they have the same number of protons. So here we have a question mark. So our options are most likely either C or D is going to be our answer, but it's definitely not A and B. So with that in mind, let's take a little track back into some history about isotopes. Isotopes and relative atomic masses. When we speak of isotopes, isotopes are atoms of the same element that have the same number of protons but different number of neutrons, right? Atoms of the same element that have the same number of protons but different number of neutrons. So for example, chlorine has 2 isotopes. You have chlorine 35 and you have chlorine 37, right? You have chlorine 35 and chlorine 37. So if you were to consider these 2 elements, if you check here, they have the same number of protons, but different number of neutrons, right? Same number of protons, but different number of neutrons. So let's go back to the question now. The question asks us, sodium 2411 and sodium 2311 are isotopes because they have the same number of protons, but different number of neutrons. All right, so that makes our answer C as in cat. It has the same number of protons, but different number of neutrons. C as in cat is our answer. All right, going on, question 6. Sulfur and oxygen are in the same group of the periodic table because, let's check A, they say they can react with each other. This is not a reason why they're in the same group. No, they can form covalent compounds. There's a question mark on that. They have the same number of electrons in the outer shell. This is a possibility. And the atomic number of sulfur is 16 and the relative atomic mass of oxygen is 16. Question mark on that. So our options, the answer could either be B, C, or D, with C looking like the most likely answer. Now, before we choose an answer, let's go back into some history. When we consider elements within the same group, elements within the same group have similar chemical and physical properties, right? And this is so because they have the same number of valence electrons. So they would have the same number of electrons in the outermost shell. So they will form the same kind of ions and they would combine the same way, right? Because of that, elements in a particular group all behave the same way. So coming back to the question, sulfur is in group 6 and oxygen also is in group 6. How do we know that? Sulfur has 16 electrons, while oxygen has 8 electrons. If we look at the electronic configuration of sulfur, it's 2, 8, 6, and the electronic configuration of oxygen is 2, 6. So what do you have in common? They have the same number of electrons in the valence shell, which is 6. So they have the same number of electrons in their outermost shell or their valence shell. So the answer to the question, as we suspected, is C as in cat. The answer is C as in cat. All right, question 7. Item 7 refers to the following quantities of atoms. You have 12 grams of carbon, 16 grams of sulfur, 32 grams of sodium, 12 grams of magnesium. And they give you the relative mass number for carbon, sulfur, magnesium, and sodium. They ask you, which of the following pairs represent equal quantities of atoms? All right, so you see this question and it asks itself what they mean, what they're trying to get me to do. So what we're going to do, we're going to check to see how much of the carbon in grams we have, and then we make the comparison to the relative mass number that they give us, right? How are we going to do that? We just simply divide one by the other. So they give us 12 grams of carbon, and we have the relative mass number as 12. So 12 grams over 12. 12 on 12, so the relationship here is 1. So next thing we're going to check is the sulfur. Sulfur here has a relative mass number of 32, but sulfur in grams, we have 16 grams of sulfur. So we take the 16 grams of the sulfur and we divide it by the 32, right? And 16 on 32, that is equal to a half. All right, so then we have 23 grams of sodium and the relative mass number is 23. So let us compare that one. So that's 23 on 23. And that is the same as 1, right? And then we have magnesium. We have 12 grams of magnesium. And magnesium, the relative mass number is 24. So that is 12 on 24, right? Which is equal to a half, right? 12 on 24, which is equal to a half. So they ask you, which pairs which pairs or which of the following pairs represents equal quantities of atoms? Which of the following pairs represents equal quantities of atoms? So 16 on 32 has half the amount of atoms, and 12 on 24 has half the amount of atoms. So 16 on 32 and 12 on 24 is providing equal amounts or equal quantities of atoms. So my answer would be 2 and 4. 2 and 4. Right? So my answer to this question will be D as in dog, 2 and 4. All right, 2 and 4, D as in dog, is my answer to this question. All right, question 8. An ion with a single negative charge may be converted into a neutral atom by, so they're saying if I have some element X and it has a negative charge, if I were to lose this electron, it would be now an atom because it will have no charge on it, right? So how do we go from this here to this here? Is that we lose an electron. So by losing an electron, the element that is negatively charged can be now become neutral. It has a saying, if you get the negative people out of your life, you become positive, right? So the more electrons it loses, the more positive the atom becomes. And if there's one negative charge, it will go from -1 to 0. All right, and if it loses another electron, it will go from 0 to +1, and so on. So the answer is C as in cat, by losing an electron. All right, next question. Question 9. Sodium reacts with water according to the equation that is given below. All right, the molar volume of gas is 24 liters at room temperature and pressure. The number of liters of hydrogen at room temperature and pressure liberated when 0.1 mole of sodium reacts with excess water is, and they give you 4 options. You have 1.2, 2.4, 12.0, and 24.0. So the first thing we need to check and see how many moles of sodium reacted with hydrogen gas, right? Because they say the number of liters of hydrogen gas liberated when 0.1 moles of sodium reacts with excess water. So we need to find out the relationship between the hydrogen and the sodium. Hydrogen has a 2 in front of it, so we have 2 moles of sodium has a 2 in front of it. So we have 2 moles of sodium reacting in a mole ratio with 1 mole of hydrogen gas, right? So it's a 2-to-1 ratio. So which means to say that if I have 0.1 moles of sodium, which is 0.1, right, of sodium, then I will have half of 0.1 moles of hydrogen gas. I'll have half of 0.1 moles of hydrogen gas. And half of that is 0.05. All right, when you use a calculator, half of 0.1 is 0.05. Now, they tell us the molar volume of gas is 24 liters at room temperature and pressure. So all I need to do now is take that 0.05 and multiply it by 24. So 0.05 multiply by 24. And the answer from that is my answer. All right, 0.05 by 24. And you should get your answer as 1.2 liters. All right, you should get your answer as 1.2 liters. A as in apple should be your answer for this question. All right, moving on, question 10. A new element, R, shows chemical properties similar to the element sodium. What is the correct formula of a compound formed with R and sulfur? Right, so R is similar to sodium. Sodium is Na plus, right? Sodium is Na plus. So therefore, if R is similar to sodium, R is also R plus, right? Because it has similar properties to sodium. So if sodium reacted with sulfur, sulfur is S2 minus. Why sulfur is S2 minus? Sulfur has two free spaces in its outermost shell so that two electrons can be added to make it stable, right? So if Na was to bind with sulfur, we would have ended up with Na2S because the charges would be swapped. The charge on the sulfur becomes the value for the sodium, and the charge on the sodium becomes the value for the sulfur, right? So when we compare both, we end up with Na2S. So if we were dealing with R, we would have ended up with R2S because R has the same chemical properties as the sodium. So we're looking for R2S. It's not A, it's not B. CR2S, our answer should be C as in cat, R2S. All right, the answer is C as in cat, R2S. Okay, question 11. Barium is below calcium in group 2 of the periodic table. When both metals react with water, the main difference in observation would be the rate of reaction and the solubility of the product, right? Barium is below calcium, so whether it is soluble or insoluble or slightly soluble is what we are checking for. The solubility of the product is the next thing that we'll be comparing. The calcium hydroxide is slightly soluble in comparison to the barium hydroxide, right? So they are being reacted with water. When both metals react with water, they ask you to which one is going to be soluble. Now the word soluble means the ability to dissolve, right? So the main differences, the main differences that would be observed is the solubility of the product as well as the rate of the reaction. So our answer to this question is D as in dog, the solubility of the product. Question 12. Item 12 refers to the following information. You have elements 1, 2, 3, and 4, and the atomic number of these 4 elements are 3, 6, 17, and 18, right? So they say which 2 of the elements above, when combined with each other, forms mainly ionic compounds, right? Now, when we have something that is ionic, we have a metal bonding with a non-metal to give you a stable structure. So we are looking for which one, when combined, would give us a stable structure, right? Which one, when combined, gives us a stable structure. So let's look at the first one. This has 3 elements, so it will be 2 in the first shell and 1 in the second shell. This one has 6 elements, so this would be 2 in the first shell and 4 in the second shell. This one has 17, so it's 2 in the first, 8 in the second, and 7 in the third. And this one has 18, 2 in the first, 8 in the second, and 8 in the third. All right, so let's see which ones we could cancel out. This fourth one here, which is 18, is already a stable structure because it has completely filled shells. So this will not react with anything. This is most likely some noble gas. The first one, 2 and 1, so this could give up 1 electron to become stable, and the third one could accept 1 electron to become stable. So it looks like 1 and 3 is our possibilities. All right, let's check. 1 and 2, no, it's not 1 and 2, 1 and 3. So B is our most likely answer. B as in boy, 1 and 3 is our most likely answer. B as in boy, 1 and 3. All right, then come to the questions that I had on the screen. Items 13 to 14 refer to the following structures. Refer to the following terms: giant ionic structure, simple molecular crystal, macromolecular structure, and giant covalent structure. Match each substance below with one of the terms above, each of which may be used more than once, or not at all. Right? So when we speak of calcium chloride, we are talking about a metal with a non-metal. A metal, calcium is a metal, which is Ca2+, and chlorine is a non-metal. When we have a metal bonding with a non-metal, we have ionic bonding, right? When we check back here, we have giant ionic structure, right? So the type of bond that will be taking place in calcium chloride would be giant ionic bonding. The next option we have, number 14, we have starch. When we look at starch, starch is a sugar. Starch is a polysaccharide because it's made up of many units of glucose, right? Starch is made from glucose. Starch is made from glucose, and many glucose units, which are monomers, come together to give you a polymer or a polysaccharide. The word saccharide means sugar, so we have many sugars bonded together to give us starch. They say, what does this have to do with anything? This structure would be a macromolecular structure, or a giant molecular structure that will be formed in starch. So we look at the options. We have giant ionic, it will not be giant ionic. We look at simple molecular crystal, it will not be simple molecular. We're looking at macromolecular because it would be a molecular structure that is formed, that is big. And you have giant covalent. It will not be giant covalent. So our option here is C as in cat. So for number 13, calcium chloride forms a giant ionic structure, while starch would form a macromolecular structure. All right, the answer to 13 is A, and the answer to 14 is C as in cat. All right, question 15. A separating funnel can be used to separate a mixture of, they have water and ethanol, water and kerosene, water and solid sodium chloride, kerosene and solid sodium chloride. So let's check it out. If we have water and ethanol, we would need fractional distillation to separate these two because these are immiscible liquids and they have different boiling points. So we could use a fractional distillation to separate water and ethanol. So it will not be A. Next, we have water and kerosene, but what they didn't put here is oil. This is kerosene oil, right? Water and kerosene, this is like water and oil. It will not mix together. They will form two separate layers, and we may be able to use a separating funnel to separate them. All right, so let's take a look at what this would look like in a lab, if you were to have to do it, you would have one layer, the oil layer would be on top and the water layer would be to the bottom, right? Because one is less dense than the other. So one would float and the other would sink. If there's an oil spill and you were to be in the ocean and you see the oil spill, you'd see the oil on top of the water in the ocean. The same principle will apply here. The oil will be on top of the water. Right? So basically what they can do is they can run off the water until it reaches close to this interface right here. Then run off this part in a separate container and then collect the kerosene separately. So they could collect that part and collect this part, and then they would just have a small interface here that would be difficult for them to separate, right? But the majority of the kerosene oil and the water would be recovered. So let's go back to the question. A separating funnel can be used to separate a mixture of water and kerosene. So the answer to question 15 is B, as in boy. All right, so are we good so far with questions 1 to 15? Any questions on that thus far? Okay, so I want to look at questions 16 to 30 now. Okay, question 16. Which of the following substances, when added to pure water, significantly, and they put that in capital letters, increases the water's conductivity? When we speak of conductivity, we are talking about the ability for something to conduct electricity, right? Or to allow an electric charge to pass through it. So our options are A, graphite. Now graphite, in its molten state, in its liquefied state, is able to transmit an electric charge. Iron 2 hydroxide and copper 2 hydroxide are insoluble in water, meaning they don't dissolve. So therefore, it will be difficult for them to conduct electricity. And the next option we have is the sodium chloride, which is salt, right? Salt, if we were to add salt to pure water is water that only have water molecules in it. So if we were to add salt to it, salt would be adding ions, which is sodium ions and chloride ions, and it would increase the conductivity of the water significantly. All right, so our answer looks like D as in dog, sodium chloride, Na plus and Cl minus. Question 17. A solution having a pH of 1 will, we have neutralized a solution of pH 4, react with zinc metal to produce hydrogen, react with zinc metal to produce a solution of pH 10, react with hydrochloric acid to produce a salt and water. So let's put that into perspective. A solution that has a pH of 1, it means to say that that solution is very acidic. If that solution has a pH of 1, that solution is very acidic. So if it is acidic, it cannot neutralize another acid, right? It takes a base to neutralize the acid. But here, all we have is an acid which has a pH of 1, and that is neutralizing a solution of pH 4, right? This cannot happen. Neutralizing a solution of pH 4, not possible. It needs to be a pH that is over 7 for it to be neutralized. Then they say it reacts with zinc metal to produce hydrogen gas, and that is correct. An acid plus a metal gives you a salt and hydrogen gas. So this here is possible. They say it reacts with zinc metal to produce a solution of pH 10. No, it wouldn't react with zinc to produce a solution that is alkaline. All right, it would not produce that. It would produce a salt and hydrogen gas, not a salt and a base. It reacts with hydrochloric acid to produce a salt and water. An acid reacting with an acid cannot produce salt and water. If the solution has a pH of 1, it's acidic, so therefore it would not react with another acid to produce salt and water. An acid reacts with a base to give you salt and water, not an acid and an acid. So in this instance, we have B as our answer, B as in boy. It reacts with zinc metal to produce hydrogen. So our answer is B as in boy. Next question, question 18. This question is a repeat question from one of the previous papers that we would have done. Which of the following halogens is a liquid at room temperature? So we have chlorine, bromine, fluorine, and iodine. As you go down the group, it moves from gas to liquid to solid, right? Fluorine is a gas at room temperature. Chlorine, gas. Bromine, liquid. Iodine, solid. All right, so our answer is bromine, which is a liquid at room temperature. So the answer should be B as in boy, bromine, which is a liquid at room temperature. All right, so question 19. Question 19, we have a weak acid is best described as one that yields a, and we have A, B, C, or D as our options. A low reading on the pH meter, B, a low concentration of acid in aqueous solution, C, a high concentration of hydrogen ions in solution, and D, low concentration of hydrogen ions in aqueous solution. Right, so these are our 4 options at the moment. So the first thing we need to do is try to go back and see if we could recollect or remind ourselves what is the difference between a weak acid and a strong acid. So strong acids are basically molecules that completely dissociate into their ions when it is in water. So when we talk about strong acids, it means to say that all the atoms become ions completely. With weak acids, only some of their atoms becomes ions because of a strong acid solution is very low, right? So when we talk about low, we are talking about pH of 1, pH of 2, pH of 3. When we talk about a weak acid, we are talking about above 3, 3, 4, 5, 6. We're talking about a weak acid, right? The number of H plus ions that are present in strong acids compared to the weak acids, strong acids releases all their H plus ions, while weaker acids, they do not release all of them, they only release some of them. So with that in mind, let us now go back to the question at hand. So let's take, for instance, a weak acid is best described as one that yields a low concentration of H plus ions in aqueous solution, right? A low concentration of H plus ions. So when we look at it, we can see now that because not all of the H plus ions are being completely converted from its atomic state to its ionic state, then we are dealing with a weak acid. So the answer to question 19 is D as in dog. All right, so moving on to question 20. Which of the following methods may be used in the preparation of barium sulfate in the laboratory? Now, barium sulfate is normally a white precipitate, right? When we consider barium sulfate is usually a white precipitate. Okay, just give me a minute. Yes, talk to me.
Hi, Emmanuel. Good afternoon. I just want to address these students for like about 2 minutes. Would you be able to just stop the recording, please? Or pause it? Thanks.
All right, back to question 20. Which of the following methods may be used in the preparation of barium sulfate in the laboratory? Now, because barium sulfate forms a precipitate, right? The method that most likely will be applied will be precipitation. Because barium sulfate forms a precipitate, the method that most likely will be applied will be precipitation. So let's go back and see how is barium sulfate actually prepared. So if we had a solution of sodium sulfate and barium chloride, when we mix them together, it gives us barium sulfate, which is a white precipitate, right? And this white precipitate is what we're trying to get. So how do they go about doing it? You take two solutions of soluble substances and mix them together, right? And the white precipitate, the barium sulfate, is formed. So what we can do with that barium sulfate now, we can take it and filter it. So the precipitate is filtered off using a filter funnel and filter paper. The precipitate remains inside of the filter paper, while the filtrate is separated from the precipitate. The filtered precipitate could then be washed several times with pure water, right? The reason why we would wash it is to purify the precipitate, all right? The pure insoluble barium sulfate is going to remain inside of here, but as we add water to it, we continuously wash the precipitate, right? We can then carefully scrape it out of the filter paper and allow it to dry in a heating oven or a drying oven, and that way we will collect our precipitate. So back to the question, which of the following methods is used to prepare barium sulfate in the laboratory? And the answer is C, precipitation. All right, precipitation is the method that is used to prepare it. C as in cat. All right, next question, 21. Which of the two following statements describes acid salts? Which of the following two statements describe acid salts? So you have one, their anions cannot dissociate to give hydrogen ions. Then we have they form a normal salt when all replaceable hydrogens of the acid is removed. Their ions cannot dissociate to give hydrogen ions, and they are not capable of generating a normal salt. So let's take our tack back as to see what is an acid salt and what is a normal salt. A normal salt is formed when all of the replaceable H plus ions in the acid have been completely replaced, right? So all H plus ions have been completely replaced. So if I have H2SO4, all of the H plus ions have been replaced. So I have no more H plus ions present, right? If I have hydrochloric acid, HCl, all the H plus ions in the hydrochloric acid has been replaced. But if I have an acid salt, it means to say it is formed when the replaceable H plus ions in acids are only partially replaced. So not all the H plus ions are removed. For example, I have H2SO4 and I only remove one H plus ion, so I end up with NaHSO4. I still have hydrogen present. The presence of the H plus ions help me to recognize that I'm dealing with an acid salt and not a normal salt. So with that in mind, let us go back to our question. So the question, they say one, the anions cannot dissociate to give hydrogen ions. So which two of the following statements describe acid salts? The anions, now remember cations are positive ions, anions, the negative ions, positive and negative ions. So we have two. They form a normal salt when all replaceable hydrogens of the acid is removed. So we know definitely 2 is not the answer, right? Because if it's an acid salt, it can't form a normal salt, right? The only way it can form normal salt is if all the H plus ions are removed. And if all the H plus ions are removed, then we're not referring to acid salt, right? So they form a normal salt when all replaceable H plus hydrogen of the acid is removed, it would form a normal salt if all are removed, but they ask us to describe acid salts. Number 3, their anions can dissociate to give hydrogen ions. All right, so this question have a repeat. The same thing they have for part 1, they have with something similar here in part 3. So they have in part 1, it cannot dissociate, but in part 3, it can dissociate, right? So this question is one of those tricky questions where the answers are very close. So in 1, they're saying it cannot dissociate, but in 3, they're saying it can dissociate. All right. Part 4, they are not capable of generating a normal salt. They are not capable of generating a normal salt. All right, just tell them a pause for a pause. This question is not clearly stated, but the answer I have for now is 1, the anions cannot dissociate to give hydrogen ions. And 4, they are not capable of generating a normal salt. I have 1 and 4 as the answer. B as in boy. All right, but I have to check this back. I have 1 and 4B as the answer, but I have to check that back. All right, question 22. In which of the following reactions is sulfur dioxide acting as an oxidizing agent? All right, in which of them is sulfur dioxide acting as an oxidizing agent? Just to remind ourselves, OIL, oil, RIG, correct. Right, so oxidation is the loss in electrons or the gain in oxygen. Right, so SO2 became SO3. So sulfur dioxide became sulfur trioxide. So it gained oxygen. All right. But if we were to look at the charges on it, sulfur went from being, oxygen is 2 minus here. So that is 2 2s are 4, so sulfur is plus 4. So it went from plus 4 O2 minus to plus 6 2 minus oxygen. So it's 3 2s are 6 for the oxygen, and sulfur is plus 6 to make this balance off. So the sulfur here went from plus 4 to plus 6. Right? So there's an increase in the oxidation number. All right? So if the oxidation number increases, that means to say we are dealing with a reducing agent. Right? Oxidation would have taken place. So the oxidizing agent is itself reduced, and the reducing agent is itself oxidized. So this is not our answer. So let's try the second one. All right, now they ask you which reaction is sulfur dioxide acting as an oxidizing agent. So we go in, SO2 became S, sulfur. So here it went from minus 2. 2 2s are 4, so this is plus 4 to balance this off to make this 0. So sulfur is going from plus 4, and on the other side here, sulfur is 0. right? So it went from +4 to 0. So in order for that to happen, it would have lost electrons, O-I-L. Lost in electrons is oxidation. So it went from +4 back this way, +3 +2 +1, 0. It went from +4 to 0. So that means to say that the loss in electrons, so it is reduced. So therefore, it is acting as an oxidizing agent in this one. Right? So a reduction in the oxidation number tells us that we're dealing with an oxidizing agent. So our answer here is B as in boy. If we were to look at the third option, here sulfur, oxygen is -2, so sulfur is +4. Why it is +4? Because 2 2s are 4 oxygen, and to balance it off, sulfur needs to be +4 to balance -4. On the opposite side, we have H2SO3, oxygen is -2, 2 3s are 6, hydrogen is +1. All right, so sulfur needs to be 2 3s are 6, sulfur needs to be +5. No, 1 by 2 is 2, so this here is 2, and then this needs to be +4. So the oxidation number of sulfur in part C is the same. Sulfur is +4 on this side, and sulfur is also +4 on this side. So it doesn't change in C, so which makes A and C out. And then let's look at D. You have sulfur dioxide on this side. Oxygen is -2. 2 2s are 4, so this makes sulfur +4. On the opposite side, it becomes H2SO4. So oxygen is -2. 4 2s are 8. So hydrogen is +1. 1 by 2 is 2. 2 plus 6 is 8. So sulfur is +6. So sulfur went from +4 to +6. So there is an increase in the oxidation number. So it is acting as a reducing agent and not an oxidizing agent in this case. All right? Because the oxidation number increased rather than decreased. So if it increased, lost in electrons increases the oxidation number, making it more positive, and thereby it will not be acting as an oxidizing agent, but a reducing agent. So that leaves us with B as the answer. So the answer should be B as in boy. B as in boy should be our answer. All right, the ON here refers to oxidation number. OA is oxidizing agent. ON is oxidation number. RA is reducing agent. All right, so our answer to this question is B as in boy. B as in boy. All right, next question, 23. In which of the following compounds does hydrogen have a negative oxidation number? In which of the following compounds does hydrogen have a negative oxidation number? Now remember, hydrogen has 1 electron, which means to say it has 1 proton. Right now, for hydrogen to become stable, hydrogen could either accept an electron to become stable, or it could lose this electron and have to become stable. In either case, it would change whether hydrogen has a positive charge or a negative charge. Now, to make it simple for us, when hydrogen is bonded to non-metals, the oxidation number of hydrogen is +1. When hydrogen is bonded to metals, the oxidation number is -1. So we are looking for an option where hydrogen is bonded to a metal. Right? Carbon is not a metal. Hydrogen to oxygen, this is not a metal. That's a peroxide we're dealing with. Hydrogen to nitrogen, that is not a metal, but sodium is a metal. Hydrogen to sodium, that makes our answer D as in dog. All right. Question 24. When an exothermic reaction occurs, energy is, this is a repeat question from one of the previous papers, energy is released in the environment. Exo, as an exit, more energy is given off than absorbed. Energy is released into the environment. That's why exothermic reactions are explosive, right? Exotron, more energy is released into the environment than is absorbed. So our answer is B as in boy. Lesson 25. Which of the following observations is expected with the electrolysis of concentrated sodium chloride solution using graphite electrodes? Which of the following is expected with the electrolysis of concentrated sodium chloride using graphite electrodes? Now, anions go to the anode, right? And these are your negative ions. So if I have sodium chloride, then chlorine ions would go to the anode, Cl minus ions, because they are all negative ions. While the sodium ions, Na plus, would go towards the cathode, right? Cations go to the cathode, anions go towards the anode. So they tell you which of the observations is expected with electrolysis. Chlorine is evolved at the anode. Yes, that is correct. Chlorine is indeed evolved at the anode. The pH of the solution decreases? No. Oxygen is evolved at the anode? No. Sodium is discharged at the cathode. Yes, sodium is in solution. All right, so B and C is out. So the options is either A or D. All right, but we have concentrated sodium chloride. So the chlorine is going to be evolved. And the sodium will end up binding with the hydroxide ions in the water because it's concentrated sodium chloride in solution. So it will have water molecules, you have OH minus ions. So sodium would most likely bind with OH groups. So A is our most likely answer. Chlorine is evolved at the anode. All right, question 26. A solution X is added to acidified aqueous potassium iodide, which turns brown. Addition of starch to the solution results in a dark blue coloration. It is possible that the solution X contains, so X is added to aqueous potassium iodide, which turns brown. Okay. It is possible that the solution X, so from that to a dark blue color. All right. It is possible that solution X contains an oxidizing agent. It's possible. If it changed to brown with potassium iodide, yep, most likely it's a ionized oxidizing agent. Well, this is one which is kind of tricky, but the answer to this one is D as in dog. '27. In which of the following substances will electrolysis not occur when an electrical current is passed through it? All right, so dilute sulfuric acid, yes, because it would be in ionic form. So there's possible for current to pass through it. Solid sodium chloride, no. Salt in its solid state will not allow current to pass through it. Molten sodium chloride, liquid form, yes. Sodium hydroxide solution, yes. So the answer is B. right? Because they say will not allow any an electrical current to pass through it. So the answer should be B, I believe, as in boy. Solid sodium chloride will not allow electricity to pass through it. B as in boy. 28. Which of the following factors will usually increase the rate of catalytic decomposition of hydrogen peroxide? Catalytic decomposition. If we increase pressure, it would increase the rate at which hydrogen peroxide will decompose. Increasing temperature, well, it may not do that because hydrogen peroxide needs light. It decomposes in the presence of light. So if we were to apply an external pressure, that may cause it to happen. Using a larger volume of hydrogen peroxide, no. A larger volume means that this will take a longer time. Using the catalyst in lumps rather than powdered form, no, this would take a longer time if we add the catalyst in lumps. So the answer should be B as in boy, applying a greater external pressure. All right, so which of the following factors will usually increase the rate of catalytic decomposition? B as in boy is the suggested answer, applying a greater external pressure. B as in boy. 29, which of the following substances is an amphoteric oxide? Now, if you try to remember what an amphoteric oxide is, we are dealing with an oxide that has the ability to act as both an acid and a base, right? This is another repeat question. Aluminum oxide is an amphoteric oxide. All right, aluminum oxide is our amphoteric oxide. All right, and 30, which of the following diagrams best illustrates the cause of an exothermic reaction? Right, the cause of an exothermic reaction means more products are given out than reactants. So that is reflected of this energy profile diagram where products is lower than reactants. It will not be where reactants is more than products. So it will not be B. It will not be where reactants and products are the same. It will not be C. And it will not be where reactants and products are the same. It will not be D. So that leaves us with A as our option, and A is our most likely answer. All right, more products, more energy is given off than absorbed. All right, so that takes us to question 30. All right, now in the interest of time, I'm going to try to go through the next 30 questions with you. All right, so we can do that together. We will do it 15 at a time. Just in the interest of time, so we will still finish well on or before 8 o'clock. All right, any questions thus far on the next 15 questions that we just did? Are we okay with that? So question 31, all members of a homologous series, all members of a homologous series have similar chemical properties. All members of a homologous series have similar chemical properties, means to say that they behave the same way, right? They have similar chemical properties. They behave the same way. So 31, the answer should be C as in cat. They have similar chemical properties. They behave the same way. All right, question 32. Item 32 refers to the following graphs, which shows the boiling point of some straight chain alcohols. Okay, so they say, which of the following molecular formula represents the alcohol whose boiling point is 180? So we're looking for 180 between 150 and 200. So that means if it goes up 50, 60, 70, 80, 90, 200, each one is 10. So that means 50, 60, 170, 180. So we're going across on this line here. All right, so at this point here, we're coming down and we check and see the number of carbons there. And that number is 7. So number of carbon atoms in the chain is 7. So we're looking for something that has 7 carbons present in it. And that would give us the alcohol. So these are all alcohols that they have here, but we want 7 carbons. So this is 5. The first one here is 3 carbons plus 1 is 4, so it's not this one. This is 4 plus 1 is 5 carbons, it's not this one. 5 plus 1 is 6 carbons, it's not this one. So 6 plus 1 is 7 carbons. Most likely it is D as in dog. All right, so there are 7 carbons inside of this structure here. All right, it didn't require you to know. All you needed to do was interpolate the information from the graph to find out how many carbons are present and then check in the answers to see which one have 7 carbons in it. All right, so our answer is D as in dog. Question 33. To which homologous series does the following structure belong? Now, in order for us to answer this, we need to figure out what is the functional group that is present. When we look, we see C double bond O, OH. Right? So C double bond OH is typical of a acid. Alkanes have single bonds. Alkenes have double bonds. Alcohols have the presence of a OH group, but acids have C double bond O, OH. So we are looking at possibly an acid. The functional group for an acid is C double bond O, OH. All right, so to which homologous series does the following structure belong? The answer is A as in apple, acids. All right, question 35. Well, 34. Item 34 and 35 refers to the following chart showing the conversion of ethene to different products. Right, so you have ethene in the presence of sulfuric acid and water gives you some product 1. And then ethene gives you polyethylene. And then ethene in the presence of bromine gives you some product 2. And they ask you, what is the product 1? The product 1 is most likely the ester. Ethyl ethanoate is the ester. So it's most likely D as in dog. All right. The alkene in the presence of concentrated sulfuric acid and water would give you the ester. All right, ethyl ethanoate. And then ethene in the presence of bromine. The product polyethylene is a solid. Then that's two. Polyethylene is a solid. All right, polyethylene is a solid. It wouldn't be a liquid or a gas. That's a solid that we can extract. Polyethylene is a solid. So the answer for 34 would be D and for 35 would be C. All right, for 34 it's D, and for 35 it's C as in cat. 36. Which of the following reactions occur between propene and bromine? Which of the following reactions occur between propene and bromine? So in order for us to answer this question, we need to see what reaction would take place. If I have propene and I was to add bromine to it, what is going to happen? This double bond is going to break and bromine is going to be added across the double bond, right? The double bond is going to break and bromine is going to be added across the double bond. Hence, I would have bromine here and bromine there. All right, that means to say that bromine is added on to the propene, right? bromine is added on to propene. So let's see what answers we have. They have substitution. No, this answer is wrong. It will not be a substitution reaction. It will be an addition reaction. So the answer to this one should be A. Between propene and bromine, you will have an addition reaction. The answer should be A as in apple, not C as in cat. All right? So it's not C as in cat. The answer should be A as in apple. '37. The forward reaction, so item 37 and 38 refers to the following equation. Organic acid plus alcohol gives you an ester plus water. So the forward reaction is known as, so acid plus alcohol to give you an ester, that's esterification. And ester plus water would give you alcohol plus acid, that would be hydrolysis. So you'd have esterification in the forward reaction, but hydrolysis in the backward reaction. The reverse reaction is known as hydrolysis. So for 37, the answer is C as in cat, esterification. But for 38, the answer is B as in boy, hydrolysis. All right, so in the forward reaction, we have esterification. In the backward reaction, we have hydrolysis. The answer to 37 is C as in cat, 38 is B as in boy. 39. When large alkane molecules are cracked, the products are a mixture of large alkane molecules are cracked, you end up with smaller alkanes plus alkene molecules. All right, so the answer here should be D as in dog. We end up with smaller alkanes plus alkene molecules. The answer is D as in dog. Question 40. Which of the following reagents can be used for converting ethanol to ethanoic acid? All right, so we need acid conditions, H+, plus we need an oxidizing agent, and potassium dichromate, all right, K2Cr2O7 is an oxidizing agent under acidic conditions, can convert an alcohol to an acid. Our answer is C as in cat. An oxidizing agent under acidic conditions can convert an alcohol to acid. The answer is C as in cat. All right, question 41. The fermentation of sugars using glucose as the substrate can be represented by the equation. If glucose is the substrate, we'll have glucose in the reactants. The fermentation of sugar using glucose as the substrate. Glucose reacting to give you ethanol plus carbon dioxide gas. So we're looking for ethanol and carbon dioxide gas. That would be this here and that there. The answer should be C as in cat. Glucose, C6H12O6, gives you C2H5OH, which is the ethanol, plus carbon dioxide gas. Answer is C as in cat. All right, question 42. Glucose is converted to starch or cellulose by condensation polymerization. All right, it will not be oxidation and reduction. It will not be dehydrogenation. So it will either be an addition polymerization or condensation polymerization. Glucose is not an alkene, so therefore it will not be addition polymerization, right? Glucose will undergo condensation polymerization because when the polymer is formed a molecule of water is removed, right? When the polymer is formed, a molecule of water is removed. So this here is one glucose unit, and this is a second glucose unit. And when they come together, water is removed, as in here, and we have the formation of the polymer on this side, right? With the peptide, with the linkage, right? This is a glycosidic linkage. And because of that, we're dealing with condensation polymerization. We have two types of polymerization. We have addition polymerization and we have condensation polymerization. When we deal with addition polymerization, we are normally dealing with an alkene that is giving us the polyalkane, but it's called the polyalkene, right? Because it moved from having a double bond present to only single bonds present. When we deal with condensation polymerization, right, that is normally when we have the formation of polyamides, we have the peptide linkage. And when we're dealing with polyesters, we have the ester linkage, all right? Peptide linkage and the ester linkage, those two linkages normally tell us that we're dealing with condensation polymerization. Right, these are examples of condensation polymerization. Getting back to our question, with glucose, we have condensation polymerization. D as in dog is our answer. All right, question 43. Which of the following features belong to metals? Which of the following features belong to metals? Okay, so metals, they form solid chlorides. Yes, we could have a metal chloride, that is a solid. They form basic oxides. Yes, they form basic oxides. And they conduct electricity when molten. Okay, I would go with 1 and 2 as my answer, because not all of them are able to conduct electricity when molten. All right, some metals are not as reactive. So A1 and 2 only, I would say 1 and 2 is my answer. A as in apple. All right, next question. Which of the following processes produces a gas which is different from the others? It produces a gas that is different from the others. Respiration in animals, carbon dioxide and water. Heating calcium carbonate gives you carbon dioxide and water. Oxidation of carbon monoxide would give you carbon dioxide. So photosynthesis would give you oxygen gas. This is the reverse. Plants take in carbon dioxide and give out oxygen. So B is our most likely answer. It's the opposite. That's the only one that will give you a different gas. (45). Which of the following metals will not displace hydrogen from dilute hydrochloric acid? Which of the following metals will not displace hydrogen from dilute hydrochloric acid? So we're looking for something that is below hydrogen. This is another repeat question. We're looking for something that is below hydrogen. And if we were to look at the reactivity series, copper is below hydrogen in the reactivity series. So hydrogen, then copper, then mercury, then silver, then gold. So copper is below hydrogen. So our most likely answer is C as in cat. Iron and zinc are above hydrogen, so therefore they would replace hydrogen, but not copper. So the answer is C as in cat. Next question, 46. Which of the following methods is used for the extraction of aluminum? Electrolysis of its molten oxide, A as in apple. All right, the answer for this one should be A as in apple. Electrolysis of its molten oxide, A as in apple. That's a repeat question. All right, 47. Which of the following statements about sulfur are true? Which of the following statements about sulfur are true? Sulfite is used in the vulcanization of rubber. Yes, sulfur is used in the vulcanization of rubber. One. It is used to extract in the extraction of iron from its ore. No, it's not used in the extraction of iron from its ore. It is used in the manufacture of explosive. Yes, the answer is possibly 1 and 3. B as in boy, I believe, is the most likely answer here. B as in boy. Is used in the vulcanization of rubber. Is used in the manufacture of explosives. 1 and 3. B as in boy is our answer. 48. Which of the following substances conducts an electric current but remains chemically unchanged? Which of the following substances conducts an electric current but remains chemically unchanged? That would most likely be copper. Copper generally tends to conduct an electric current but remains chemically unchanged. Copper, B as in boy. 49. Which of the following gases is not considered to be toxic? Which of the following is not considered to be toxic? Well, of these gases, the least toxic of them would be carbon dioxide. Sulfur dioxide is toxic, nitrogen dioxide is toxic, carbon monoxide is toxic. These are all toxic gases. Carbon dioxide is a gas that exists naturally in the environment and can also be made into existence by the activities of man. So even though carbon dioxide gas is bad for humans, it's not toxic when compared to sulfur dioxide, nitrogen dioxide, and carbon monoxide. So the answer in this question here would be A as an apple. That's the least wrong answer, which is the most correct answer. 50. All right, so 10 more questions to go, guys, and then we'll be to the end of this paper. 50. The compound which has the formula listed there is most likely, there's a double bond present, so we delimit a alkene. A as in apple, we delimit a alkene. All right. 9 more to go. 51. When copper 2 carbonate is heated alone in a dry test tube, a gas is evolved and a black residue is formed. This gas is expected to D, form a white precipitate with aqueous calcium hydroxide. This is a repeat question from one of the previous papers. The form forms a white precipitate with aqueous calcium hydroxide. All right, so the answer is D as in dog. Okay, next question. Item 52 refers to the experiments 1 to 4 shown in the following diagram. So you have concentrated sulfuric acid, magnesium 4 oxide plus sodium chloride, and that is heated. Okay. And then 2 concentrated sulfuric acid, magnesium 4 oxide plus sodium chloride. Okay, then 3 concentrated sulfuric oxide. They change the place in which they have the container to collect the gas. One, they have it inverted, and the next one, they have it right side up. You have magnesium 4 oxide in each case, and you have concentrated sulfuric acid. Okay, so they're asking you the question, in which experiment would the amount of chlorine gas collected be the greatest? All right, in which experiment would the amount of chlorine gas collected be the greatest? Okay, so let's see what's different. Okay, so okay, so if the gas is a heavy gas, then it will make it difficult for the gas to rise. which should make 3 and 4 out of the question and leave us with 1 and 2. But 1 and 2 looking like the same thing. I'm not seeing the difference in it. I'm looking for the difference, but I'm not seeing the difference in 1 and 2. Right, this question is an error question. So if you had to put an A or B for this question, because both of them is the same exact drawing, they would have had to give you the answer correct. No, one has heat being applied to the bottom and the next one does not have heat. I now see the difference. Okay, there's no heat being applied here, and then there's no heat being applied here. But there's heat being applied in this one and heat being applied in this one. Okay, so our answer is 2. 2 is correct. All right, B as in boy would yield the greatest amount of gas being collected. I would go with B as in boy. Right, 53, which of the following observations is expected when aqueous silver nitrate is added to aqueous potassium chloride? Which of the following is expected? Silver nitrate plus potassium chloride will give me potassium nitrate plus silver chloride. That means to say I'll get a white precipitate being formed. The answer should be C as in cat. A white precipitate is going to be formed. C as in cat. All right. Questions 54 and 55 refers to the following metals. You have aluminum, copper, iron, and sodium. A particular metal may be selected more than once or not even at all. Which metal reacts vigorously with water to produce a strongly alkaline solution? Sodium would react most strongly because it's higher up in the reactivity series than the other metals listed there. So the answer should be D for 54. Which metal has an alloy which is used in the manufacture of aircraft? Aluminum. The alloy from aluminum is normally used in the manufacture of aircraft. So the answer 55 should be A as in apple, aluminum. All right. Next question. A gas Z has physical and chemical properties similar to ammonia. The best method for collecting a pure dry sample of Z would be to pass it through calcium oxide and collect by upward delivery. All right. It has properties similar to ammonia. So if we were trying to collect ammonia gas, we would collect in an inverted tube, which is upward. And the reason for that is because the gas is less dense than air. So therefore it would rise. Right? It's less dense than air, which would cause it to rise. So the answer is B as in boy. 57. The main substances responsible for acid rain are sulfur dioxide and sulfur trioxide. All right, this is responsible for the acid rain. Sulfur dioxide and sulfur trioxide. That's another repeat question. All right, we're almost to the end. 58. Although aluminum is more reactive than iron, aluminum becomes corrosion resistant when left exposed to the atmosphere, while iron corrodes. And this is because the oxide film on aluminum protects the metal from further corrosion, but the oxide film of iron does not protect it. That is correct. The oxide layer that is formed with aluminum protects the aluminum underneath. So therefore, it allows it to become resistant to corrosion. The answer should be C as in cat. All right, next one. 59. Which of the following substances is an important constituent of chlorophyll? Right, well, this would be magnesium. This is not quite a chemistry question. This is more a biology question than chemistry. But yes, it would be magnesium is another important constituent of chlorophyll, magnesium. All right, it will not be copper or iron. The two possible options would have been either calcium or magnesium, and magnesium is your answer. D as in dog. And finally, which of the following gases will give a positive test with dry cobalt chloride paper? And that's when we're trying to test for the presence of water. D as in dog. The cobalt chloride test, water. Right, the test for water it uses the cobalt chloride paper, the test for water. D as in dog is your answer. All right, and that brings us to the end of today's session.